Hi everyone. Today we're going to be taking a little break from algebraic equations and we're going to do something that is entirely numerical. So that means that the problem for today does not involve any variables. So it's quite relieving to not have to solve for x or a or b, but today's problem is, it involves nested exponents. So that means exponents on exponents. So when you first look at this question, it may seem a little bit confusing, but that's okay because we're going to talk about how to solve this question. So if you'd like to, you can go ahead and try solving this problem on your own. Then we're going to discuss on how to actually solve it. So let's go ahead and get started. But before we talk about how to solve it, let's talk about a couple rules. So a couple rules in exponents are, the first one is raising x to the power of 1. So if you have x or 1 or -1 or -5 or 6, or no matter what you have, no matter what number you have, if you raise this number to 1, it will always give you back your original number. So that means x to the power of 1 is x, and y to the power of 1 is y. -1 to the power of 1 is also 1. -1, I mean. So this is the first rule that we're going to talk about today. Now our second rule is, raising 1 to the power of anything. So if you raise 1 to the power of 1 or 2 or 3 or infinity, or maybe even -5 or negative integers, no matter what number you raise 1 to, it will always give you back 1. So you can try as much as you like, use all the numbers you like, but no matter how many times you multiply 1 by itself, you will always get back 1. So there are two other rules that I like to talk to you about, and they are, raising raising a number to the power of 0. So raising x to the power of 0, or y to the power of 0, or any number for that instance, it will always give you, this is a bit confusing, 1. But no matter what number you have, raising it to the power of 0 will always give you back 1. So this is our third rule. And our last rule is, raising 0 to the power of anything. So I think you can guess, if you tried multiplying 0 by itself any number of times, you would always get back the same answer, 0. So that means 0 raised to the power of 1, 2, 3, infinity. No matter what you try, you will always get back 0. Sort of like 1. 1 raised to the power of anything and 0 raised to the power of anything both give back the original number, which is 0 or 1. Okay, so now that we've talked about these rules, let's go ahead and try solving our original problem. Our original problem was 2 to the power of 3 to the power of 4 to the power of 0 plus 2 to the power of 3 to the power of 0 to the power of 4 plus 2 to the power of 0 plus to the power of 3 to the power of 4. So that sounds like a funny problem. Saying it is pretty confusing, but let's go ahead and simplify it. So looking at our last rule, 0 to the power of x is equals to 0. Since no matter what power you raise 0 to, you will get back 0, we can try using that in this question. So usually what you do when you have nested exponents is you start from the top and then you go downwards solving it. But what we're going to do first is we're going to, that's what we're going to do. We're going to start from the top and then we're going to go down. So we have 0 over here, and we can notice in the first question, we have 4 to the power of 0. And what's 4 to the power of 0? 1. So we can simplify that and write that down as 2 to the power of 3 to the power of 1. And then now let's look at the second one. 4 hasn't been raised to the power of anything, so that stays the same. But looking at the question, we have 0 to the power of 4. And what's 0 to the power of anything, really? 0. So that simplifies the equation to 2 raised to the power of 3 raised to the power 0. And now we have 2 to the power 3 to the power 4. So that would give us 2 to the power 0. And now if you notice, we have 3 to the power 4. Now, what's 3 to the power 4? You can go ahead and try multiplying it, but I have the answer ready, and it's 81. Because 3, 9, 27, 81. So we have 2 to the power 3 to the power 1 plus 2 to the power 3 to the power 0 plus 2 to the power 0 to the power of 81. So now it may seem like we have, well, a simpler question, and we're going to go ahead and simplify it even more. Now we have 3 to the power of 1. Now, what is x raised to the power of 1? X. So that doesn't affect the 3, that just keeps it 3. So that gives us 2 to the power 3. Then we have 3 to the power of 0. And what is x to the power of 0? 1. So that gives us 2 to the power of 1. Now we have 2 to the power 0 to the power of 81. Now that seems like a large number, but it really isn't, because if we go back to our rule, we have 0 to the power x is equals to 0. So we replace the x with 81, meaning that we have 0 to the power of 81. And 0 raised to the power of anything is 0, so we simplify that to 0. Now we have a pretty familiar equation because it only, a pretty familiar, equation. But because over here, if you notice, all of the terms have exactly one exponent, not nested exponents, which is pretty relieving. But we still have some work to do. So we're going to go ahead and simplify the equation because we have 2 cubed plus 2 to the power of 1 plus 2 to the power of 0. So 2 cubed is, 8, because that's 2 times 2 times 2, which is 8. So we have 8. Then over here, we have 2 to the power of 1. Looking back at our rules, we have x to the power of 1, x. So that means 2. So 8 plus 2, and then we have 2 to the power of 0. And I don't think I have to remind you, anything to the power of 0 is 1. So we have 8 plus 2 plus 1. Now 8 plus 2 is 10, and 10 plus 1 is 11. So that is our answer to our question, 11. So thank you so much for watching this video, and I hope that you're walking away with a little bit more knowledge on exponents and nested exponents and how to solve this equation. So if you like this video, be sure to check out our other videos on our channel. We upload pretty much every day, so be sure to go and check that out. Thanks for watching.